I keep a wrench in my new machining cabinet that's bulkier than it needs to be. It has one job, securing the collet holder while undoing the nut, so it doesn't need to be adjustable, and something slightly more streamlined will be better. I could just buy a wrench. I'd need to cut it down to size and drill a hole to hang it. That would be much easier, but this should be a fun project, more about experimenting with new techniques like drop forging with no power hammer and no experience. And here's what I'll attempt to make, which I designed in Shaper 3D. I'll make it from mild steel, and I haven't quite decided how, but I will make the jaws from high carbon steel for extra strength. I reckon for what I'm using it for, the mild steel would be plenty strong enough, but let's try and make it properly anyway. I say properly, but there's nothing really proper about it at all. For one thing, it would be easier to make the whole thing from high carbon steel, but I don't have anything thick enough. I'll start with the handle and the ring on the end first, and that's because it's the thickest part. Then I'll reduce the shank of the handle afterwards, either by milling or forging. I was going to machine the ring, but I've decided to forge it instead, and I'll do that by making a couple of dies and then squish it down. That'll establish the thickness of the handle as well at the same time. So the first thing I need to do is drill a hole the same as this and weld a pin in one of them, so then they can all line up. Next, I'll machine a recess on the milling machine, and I'll do that using my rotary table. After centering the rotary table to the spindle, I'll then center the workpiece, and I'll do that by using the drill that I used to drill the hole, and then I'll move the table over to make the recess. I did both pieces the same. This is how I'll use them, and I've decided that the pin doesn't actually need welding in, it can stay loose. I'll set the stop on the top of the fly press to limit the travel so it doesn't squash the workpiece too far. To heat up the wrench, I'll use my induction forge for the first time in a project. I've had it nearly a year, and all I've done so far is test it out a few times. It's a very cool machine which I'm still getting to grips with, and it amazes me how this can actually work. The coils are interchangeable, and I should be using one that's just bigger than the workpiece, so what I'm doing here isn't very efficient, and using the right one would heat it up much quicker. It did work, but I'd like it a bit more defined, so I'll heat it back up and have a second go, and the pin still fits, so there's no problem there. I reckon that looks much better, so next I'll forge out the handle. I've set the depth stop again. It's one of the best features of the fly press, and it allows me to forge to a consistent thickness. With forging the handle down, I've drawn it out in length. I always knew that was going to happen, and I did allow for it, but as I'm inexperienced, I didn't get it quite right, and it's now too long. An option would have been to draw it out this way, but that's too late now. To fix it, I could heat up this section and then upset it by driving the material back into that area. Instead, I'll call it a practice piece, and it'll only take 20 minutes to get back up to the same stage, and it'll be a better job as well. I made a new coil more suited to what I'm doing, which should be more efficient. That worked great, and I should have really done that before starting. I've decided to plate safe and machine the handle. This way I don't need to worry about changing the length. I need to machine the other end of the wrench anyway, and that will be to get it ready to forge weld high carbon steel to it to give the jaws some more strength. I'll use this piece of high carbon 1075 steel, which I'll be able to harden. I'll cut two pieces which will be welded either side of the open end of the wrench. At the moment the 1075 is annealed and easy to cut. To get a successful forge weld, the two surfaces that meet need to be clean. Any irregularities will add to the chance of failure. I've only forge welded 2 or 3 times before, but I've learnt a bit from that experience, which is the whole point of trying this stuff out, and again it's the main reason for making this project. They're almost ready, they just need cleaning, which I'll do with some metho, and then I'll clamp them together and weld around the edges with the MIG welder. This will do a couple of things. It will hold it in position while I get it up to heat and forge weld the faces together, and it will also seal the gaps, which will prevent the faces from oxidizing. Another option would be to tack weld them in the corners just to hold them, then use borax as a flux to stop any oxidization. I reckon sealing up the edges with the MIG welder is the easiest and probably has the most chance of success. Also, borax eats the lining of the forge, so I think this way's got to be the best. The forge needs to be cranking up to a super high heat for this to work, and the wrench also needs a good soak in there. I think I left it for about 15 minutes. I took a second heat, which should do it. I have no real way of knowing if it worked, but I think I did everything right, so I'm fairly confident. Next I'll start grinding it back. I'll remove the scale and high spots, and then I'll use the surface grinder to get both sides flat and parallel. I was going to use the belt grinder, but I have the surface grinder, so it makes sense to use it. Now I can actually start making it look like a wrench. I'll cut out a template and stick that on with CA glue. For that I'm using Bondi Bond, which I've mentioned a couple of times recently. I've been using it heaps and it will be available very soon. There's a wait list, which I'll put a link to in the description if you'd like to get pre-launch prices. That was working, but it was a bit slow, so I'll finish cutting it out with the angle grinder. I only have a 2-inch belt grinder, so I'll have to do it using files. I do have a die grinder I could use, but I hate the sharp slithers that it makes, so I'm happy to do it by hand. Next I'll mill the inside of the jaws, and I set it up using a couple of parallels like this. They only need to be fairly accurate to the line, and doing that by eye is good enough. The main thing is that the two sides are milled parallel and 40mm apart. That fits well enough for now. I'll check it again later after it's been heat treated and make any adjustments if needed. I finished filing the back of the opening, then took it to the belt grinder and finished profiling the outside. Next I need to re-establish the handle and thin it out a bit more, which I'll do on the milling machine. It's pretty much a wrench at this point, but the next process is the whole reason I wanted to do the project. I'll attempt to drop forge my name into the handle, so the first thing I need to do is make a stamp. I'll do that by carving it into this piece of mild steel using a tiny engraving burr in the Dremel. To hopefully pull this off and do a neat job, I need to get comfortable and use the optivisors to see what I'm actually doing. The easiest way to do this would be use a fibre laser. I have been offered them, but I reckon this is much more fun. Maybe I'm a little strange, which is probably true, but I have really been looking forward to this part of the project. The straight lines are easy enough to do, but I left the two S's till the end to get a bit of confidence, and actually they weren't too bad either. The first pass is just to set it out and make something to follow. I went over it a few more times and then removed the template to see what I'm working with. After I went over it a few more times, I decided to try these cheap diamond burrs. I also set up on the workbench with the stamp glued to a piece of steel that I can rotate easily, making the process even easier. I made lots of passes checking it now and again with a piece of blue tack. I reckon it took a couple of hours, maybe 2.5 hours, and I'm pretty pleased with it. Who knows though if it's actually going to work and stamp into steel. I'm grinding the outside next on my new belt grinder, which I owe a big thanks to both Brodbeck and Gamaco. It's an awesome machine which has heaps of accessories and possibilities, making it very versatile, and I reckon a belt grinder is one of the best tools a maker can have. There's a few marks here and there where I slip, but they're very light and they won't show up, and that's even if the stamp works anyway. I'll use the fly press to do this, so next I need to weld it to a tool holder. I have a couple of spare ones left, but this jig I made for making handles will be a perfect base for it. I'll tack weld it on, and if I do need to make handles again, I can just zip it off and clean it up. Before I stamp the wrench, I'll do a test piece first. There was a fair amount of scale that I was forging into it, but it did work and it looks promising, so I'll give it a go and I'll brush the scale off before I stamp it. The clamp at the back will also be a stop, so I'll easily be able to put the wrench on quickly and position it perfectly. Even though I haven't filmed it, I brushed it at the workbench on my way over to the fly press. It worked and it wasn't too bad. I did reheat it though, and I had a second go off camera which sharpened it up a bit. I wanted to see if I could improve on it just to learn, so I heated up a scrap and had another go. I brushed it at the fly press this time, and I tried throwing the fly press rather than pressing it. Anyway, it's a touch cleaner, but I do think pressing the fly press is better than throwing it. The stamp is still in perfect shape, and I got some advice later on from my blacksmith mate Matt, which was to brush off the scale with a wire wheel in a grinder. Anyway, it was an interesting process that looks promising. I'm still making up my mind whether to add the 40mm, but next I'll add my logo. I've put the touch mark into the fly press again and positioned 3 clamps to act as stops. I need to give my mate Troy a shout out for making the touch mark for me. If you need a touch mark yourself, he can help you out with that, and I'll put a link in the description. I pressed it a bit hard and I probably should have set to stop, but anyway I straightened it back out off camera. The logo came out great though, and I've decided I will add the 40mm. First I need to mill a shallow recess. And for the lettering, I'll just use regular stamps. It's certainly not perfect, and I could definitely do better with what I've learned, but I'll clean it up a bit and see if I can make it look half decent. That looks a bit better, so next I can heat treat it. I've got the forge set to the correct temperature, so I'll put it in for about 10 to 15 minutes before quenching it in oil. Now it's hardened, it needs tempering, which I'll do in the oven. It goes in there for a couple of hours at 210 degrees C. This makes the hardened steel stronger and less brittle. For the finish, I'll nickel plate it. I've done this a few times now, and it's a really awesome finish, which is super hard and will last for years. And best of all, it's very easy to do. The only downside is it shows up every little scratch and blemish, and this wrench is full of those. It is the perfect finish functionally though, it's just going to highlight all those blemishes. The wrench needs to be very clean for the plating to work, and the solution needs heating to between 88 and 92 degrees C. It went in there for 15 minutes and it actually came out a bit disappointing. This is the first time this has happened for me. Anyway, it looks like it doesn't stick to scale, so I'll do a better job of removing that and try again. I'm scratching it off with my Niroc carbide center punch, which is working great. What I really needed to do was sandblast it before plating it the first time, which I would have done if I had a sandblaster, and it really is something that I should get. I could have cleaned out around the logo and the 40mm, but I liked how it looked, so I purposely didn't. That came out much better. It did make some of the first plating a bit patchy, but it's a great durable finish which will stop it from rusting, and it will last for years. It fits perfect, and I use it just about every time I use the milling machine, and that's most days. So even though I should have probably just bought one, it will get used, and it's not something that's just going to get stored away. Anyway, hopefully you found something useful in the video. Hopefully you enjoyed it. Thanks for watching, and I'll see you on the next one.